In order to properly compare the tax on producers and the tax on consumers, we're going to use the same demand and supply curves that we used in the previous example. So you notice here that we have a demand curve equal to 50,000 minus 12,000 P, where here, technically speaking, this is in terms of the demand price or the price to the consumer. And we have a supply curve that's equal to negative 5,000 plus 10,000 P, where here, technically speaking, P is the supply price or the price that the producer gets to keep. Again, we have a tax equal to 50 cents per unit. And we can also recall from our previous example that when we solved for the original no tax equilibrium price and quantity, we got that the equilibrium quantity was equal to 20,000 and the equilibrium price was equal to $2.50. So then we want to ask ourselves, what algebra can we do in order to figure out quantitatively what this new quantity is and what these new prices are? So the first thing that we notice is, well, what we did in order to get to this point is we shifted our demand curve vertically downwards by 50 cents. So one thing we could do is shift our demand curve down algebraically by 50 cents and then solve for our equilibrium. So as a first step, let's think about how to do that here. The first thing that we notice is that our demand curve is written in terms of quantity demanded as a function of price. It would be incorrect to just take this demand curve and subtract off 50 cents, because what that would be doing is referring to a horizontal shift of 50 cents, which is not what we're trying to do here. We see that vertical and horizontal shifts are not the same thing, so we need to think about what is appropriate to do in this case. So while it is true that we can't just subtract 50 cents from the quantity, we can in fact think about taking this price variable and moving it down. So in order to do that, we need to solve for price in our demand curve. Luckily, this is pretty simple, and we can just see here, just rearranging a little bit, we see that we get 12,000 P is equal to 50,000 minus quantity demanded. And then we can just go through and divide by 12,000 to say P is equal to 50,000 over 12,000 minus 1 over 12,000 times quantity demanded. It's not pretty, but it works. And we can say here, we can simplify a little bit, and we can say that this is equal to 50 over 12, or reducing again, 25 over 6, minus 1 over 12,000 times quantity demanded. If you recall, this is called our inverse demand curve because it represents price as a function of quantity demanded rather than quantity demanded as a function of price. So we can then say, well, what's happening here? Well, our demand curve is being shifted down. So whatever the price was at any given quantity before, now the relevant price is that old price minus 50 cents. So we need to subtract 50 cents. Okay, so our new demand curve is just P is equal to 25 over 6 minus 1 over 12,000 times quantity demanded minus 50 cents, or 1/2. So again, we can simplify this a little bit. 25 over 6 minus 1/2 is just 25 over 6 minus 3 over 6, just 22 over 6, or 11 over 3. So we can say that this new curve is equal to 11 over 3 minus 1 over 12,000 times quantity demanded. And then we can just rearrange this again and say, well, I could just put this back in terms of our normal structure as quantity demanded as a function of price. Okay, so we can just switch it back now. We can say 1 over 12,000 times quantity demanded is equal to 11 over 3 minus price. Okay, now we just multiply 3 by 12,000 and we get quantity demanded is equal to 12,000 times 11 over 3 minus 12,000 P. Multiplying this out, we can just say, well, 12,000 divided by 3 is 4,000 times 11 is 44,000. So we can say that this is equal to 44,000 minus 12,000 P. We can do a sanity check on this, and we can notice a couple of things. We can notice first that the slope of the line is the same as the slope of the old demand curve. Because we get negative 12,000 here, negative 12,000 here. If the coefficient on price in both of the equations is the same, then the slope of the lines is the same. So that makes sense because we're just dealing with a parallel shift here. So, okay, so far so good. The other thing that we notice is here our constant was 50,000 and here our constant was 44,000. If we were to graph these points, we would see that the intercept up here, which is what happens when quantity is equal to 0, does in fact go down. Because in this case here, our intercept would be 50,000 divided by 12,000, which is 50 over 12, which is 25 over 6. And in this case here, our intercept is 44,000 divided by 12,000, or 22,000 divided by 6,000. We get 11 over 3, right? Okay. We can say, well, this is a little bit less than 4, and this is in fact a little bit more than 4. So our sanity check makes sense in that we're actually shifting our curve downwards. So this is a completely acceptable way of shifting our curve. But it's a little bit messy and there's a lot of arithmetic to be done. So then we can say, well, how can we do this in a less labor-intensive fashion? To think about our second approach for creating an effective demand curve, we can remember that our original demand curve is in terms of the price that the consumer pays, and what we're really doing with this shift is we're putting our demand in terms of the price that the producer gets to keep. So you can think about the relationship between those two prices as the price the consumer pays is just the price that the producer gets to keep plus the amount of the tax. In this case, that is the price that the producer gets to keep plus 50 cents. So what we can do is we can just use this relationship here to substitute into our demand curve to put this in terms of the price that the producer gets to keep. When we do that, we get quantity demanded is equal to 50,000, minus 12,000 times the price that the producer gets to keep plus, I'll just make it easier, right, 1/2. Well, now all we have to do is multiply this out. And we can see that this is equal to 50,000 minus 12,000 times the price that the producer gets to keep, minus, don't forget to distribute your negative, 1/2 times 12,000, which is 6,000. Now, just combining like terms, we see that we get the same thing that we got before, and that quantity demanded is equal to 50,000 minus 6,000, which is 44,000, minus 12,000 times the price that the producer gets to keep. You'll notice here that we got the same answer as we got before doing this a longer way, but this was much, much less labor intensive. So given the option, I would prefer to do my math this way than to do it the previous way. But either way, mathematically speaking, is in fact valid.